Welcome to the final part of 205E, where we look at determining the size of the raceway that we're going to need for our service for our apartment buildings. As we went through our apartment example, we found that our service conductors needed to be at least 750 kc mil. Now this is all based on the minimum ampacity of our service that we have calculated. The other thing that we need to pay attention to when it comes to our service is what our voltage is. Our voltage tells us how many conductors we're going to need. A 120 240 volt service is a single phase service, meaning that we have two hot wires within this. Since it is dual voltage, that also indicates that we're going to need a neutral conductor. So this particular service is going to require 3 service conductors. Sizing the conduit for the service is fairly simple when all the conductors are the same size. All we have to do is refer back to Table 6. Table 6 is split up to different insulation types of conductors. For our service, we're using an RW90 type conductor that's rated at 600 volts, so we use Table 6A. When I go into Table 6A, I want to find the wire size. So I look in the first column and I go down until I find 750 kc mil conductors, which is on the second page. After I find the 750 kc mil conductors, I simply follow that across until I find the number 3. In this case, I follow that column up to find that I need to have a trade size 91 conduit, or a 3.5 inch conduit. This is fairly simple, and it is an advantage when we have all the conductors being the exact same gauge. That being said, we do have a cost savings opportunity to us if our service is over 200 amps. Let's take a look at Rule 418. 418 states that the neutral conductors shall have sufficient ampacity to carry the unbalanced load, and that means that my neutral should be sized so that it can carry the load that's on any one of the two hot conductors. Anytime that we have a panel that is 200 amps and less, we want to size my neutral conductor the exact same size as my hot conductor. However, because of demand loading and the purpose of the neutral, I can change that if I go over 200 amps. We have to remember that the purpose of the neutral is to carry the unbalanced load between my other hot conductors. So if I have two hot conductors, one of which has a 100 amp load on it, the other which has an 80 amp load on it, my neutral is only actually carrying 20 amps. It's carrying nowhere near the full load that either one of those two conductors is using. And even if I lost a phase, if I lost the 80 amp phase, then my neutral conductor would be carrying 100 amps, just like my other hot conductor is. Now, since I'm not likely to have as big of a load on my neutral as I do on my hot conductors, when my service goes above 200 amps, I can apply a derating factor, which is where the next set of Rule 418 comes in. It says the maximum unbalanced load shall be the maximum connected load between the neutral and any ungrounded conductor as determined by Section 8. And then we have Subrule A, which is not applicable to us right now, but Subrule B is. Subrule B says, except as required otherwise, a demand factor of 70% shall be permitted to be applied to that portion of the unbalanced load in excess of 200 amps. Subrule A talks about electric discharge lighting or nonlinear loads supplied from a 3-phase 4-wire system, but that's not applicable to us right now. So what this rule is telling me is that when I have my calculated minimum ampacity of 453.98 amps for my apartment service, my neutral ampacity can be broken down. I want to take 100% of the first 200 amps of my calculated value, and then I'm going to add that to 70% of whatever's remaining. So in this case, 70% of 253.98 amps. This means that my total demand on my neutral is only going to be 377 amps compared to the 453 amps that my line conductors are going to see. This means that according to Table 2, I could actually reduce my neutral from a 750 kc mil conductor down to a 500 kc mil conductor. So this is the first place that we can see a bit of a cost savings, and it's all because of the derating ability that Rule 418 gives us. When we derate our neutral and we end up having a different size of a neutral to our hot conductors, it does complicate figuring out what my conduit size is just a little bit. Instead of just using one table, now I have to use 3 tables. I'm going to use Table 10A, Table 8, in Table 9C. And we have to keep in mind that I have two 750 case mil conductors and one 500 case mil conductors. So I need to be able to add those together at their cross-sectional area to figure out how much I can fit into a conduit. What I'm going to do is I'm going to take the cross-sectional area of my two 750 case mil conductors and then add it to the cross-sectional area of my one 500 case mil conductor for a total area of 1,809.1 millimeters square. The next thing I want to do is I want to go to Table 8. Table 8 tells us how full can we make the conduits. If I have three conductors, Table 8 tells me I can have a maximum of a 40% fill. I want to take these two pieces of information, my cross-sectional area and my fill, and I'll take them both over to my Table 9. Table 9 is separated into different types of conduit, so I need to know that we are running this inside a PVC rigid conduit. Table 9C handles PVC rigid conduit for me, and if I find in the 40% column the number that exceeds 1,809.1 millimeters square, this will tell me what my conduit size is going to be. In this case, I can have a trade size 78 conduit, which is a 3-inch conduit. When I ran the three conductors that were all the same size, I ended up with a 3.5-inch conduit. But now that I've reduced my neutral and I saved money on buying a smaller neutral conductor, I can also reduce the size of my conduit coming into my building, also give me a second monetary saving value. So there are our two methods of finding the conduit size for a service, depending on whether or not our conductors are all the same size or if we're going to have conductors of different sizes. And we'll only have conductors of different sizes if we are over 200 amps and we are allowed to derate that neutral size. You've now completed Module 205E, so return to Blackboard and you can continue on to 205F.